Bismillahirrahmanirrahim. Dear student, today we will start new chapter. The name of the chapter is tree. The first section is introduction to tree. Here we will study the basic properties and basic results of tree. First, what is tree? See here, tree is connected undirected graph with no simple circuit. According to the definition, we have to check three things. Number one, graph must be connected. Connected means juz wahid in Arabic. Part one juz mean one part. Okay. Undirected means there is no arrow on edges, no directed edges. Okay. No simple circuit means there is no circuit in the graph. If a graph satisfy these property, mean أي graph هذا ثلاثة أشياء موجود هذا this graph is called tree. For example number one, see here the graph G1. Is this a graph is a tree or not? Let's suppose first graph. See, this is one part, mean it is connected. Mean هذا واحد جزء mean connected. There is no arrow on edges. سهم ما في موجود. هذا undirected. Simple circuit, there is no circuit here. Mean from any vertex to another vertex there is a path. Tree. So this graph is a tree. Mean it satisfies three conditions. Number one, connected, undirected, and there is no simple circuit. So this graph is called a tree. Now similarly we will check in the second graph. Is this graph is a tree or not? First we check it is connected. See here F, E, B, D, F. All this is juz wahid, mean connected. This one is connected. Second, we will see here, is this undirected graph or not? Yes, this graph is undirected because there is no arrow on the edges. So this is undirected. Also there is no circuit here. So this graph is also a tree. What about the third graph? Number one, see this graph is connected. Yes, mean it is juz wahid. Okay. Second, undirected. Yes, there is no arrow. Second one, third one is it contain a circuit or not? Let's see. A to B, B to E, E to D, D to A. This is a circuit. Mean this graph contain a circuit. Means circuit majud. So this graph is not a tree. Mafi tree hada. Asbab a circuit majud here. Mean a circuit. There is a circuit here. Now second, next graph we will see graph number 4. This graph is a tree or not? It is connected? No. See here C, E, B, D. This is a one part and AF is a second part. Mean it has just N. So this graph is disconnected. So this is not a tree. So solution graph G1 and G2 is a tree. G3 is not a tree because it contains circuit A, B, E, D, A. And G4 is not a tree because it is disconnected graph. Now we will go to the Next exercise, question number 1 and question number 2. Is the given graph a tree or not? Let's see. Diagram 1, A. A is connected. See, this I am talking about first graph. This is connected, yes. Part juz wahid, yes. Arrow majud, no. All these graph A, B, C, D, E, F. No arrow means all are undirected graph. So we only check it is connected and no circuit. Mean juz wahid and no circuit. Mafi circuit majud. Then it is T. Let's see here. A. This graph is connected and no circuit. So this graph is tree. B. This graph is contain Juzain, mean Mafi connected, mean it is not a tree. C. This graph is connected Juz Wahid. E also Juz Wahid. C and E no circuit. So these are the tree. If we will think about D, C, I will draw a C here. There is a circuit here. So this graph is not a tree. Okay. Next, if we will see here, this one, this vertex, then this again here. This one also contains circuit, so this one is also not a tree. Now the answer A, C, E, they are the tree. B is not tree because it is disconnected. D and F are not tree because B is contain a circuit and this is also contain a circuit. So these three graphs are not tree and these three are the tree. Similarly, in this question number 2, see part which graphs are tree and which graphs are not tree. All are undirected. See this contain juz A contain juz wahid mean one part mean it is connected and there is no circuit. So A part is a tree. What about part B? See this one if I go like here, 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 here to here, 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 here. Mean it is the one part, choose one, and there is no circuit. Mafi circuit majud. Mean A and B are tree. What about C? In C, I color these, and the second color C here. These are the two component. Mean Juzan. So this graph is not a tree. What about D? D is one part and there is no circuit, so this is tree. And what about E? See here. See, this is a circuit, so this is not a tree. Again, you will check F. Their graph is connected with just one, and there is no circuit. Mean this graph is also a tree. Now you will see that A, B, D, and F are tree. C is not tree because disconnected means Joseon. F sorry E is also not tree because this contain a circuit. Okay. Now we will see this definition. Now if a connected disk graph is forest if each of its component their component is a tree. Mean let's suppose if we consider this graph, this is a graph, one graph. So the first part is also a tree, this is also a tree. If any graph it has more than one component and all components are tree, then it is called forest. Mean if graph has juice mean juice more than one and all juices are tree is called the forest. So this is the definition of a forest. And by this definition, we will see here if the graph is connected in section 10.4, there is a path between the two different vertices. Now, if the path is unique, then it is called tree. Mean there is no second path. Only exactly one path from any two vertices is called the tree. If there is a unique path between two vertices is called the tree. If it is tree, then there is a unique path between the two vertices. Mean a graph is tree if أي اثنان نقطة there is a exactly one طريق between them and vice versa. उलट mean reverse. If أي اثنان نقطة there is only one path mean طريق, then it is called tree. So this is the first theorem. Now we will definition the second definition. What is a rooted tree? A rooted tree in which one vertex has designated as a root and other vertices every edge is directed away from the root. For example, if you will see this graph, this diagram, if this is A is a root, then see B, F, G are away, mean barra, away from the F. So these called are the, if all the things are like that, all the vertices are away from this one, then it is called the rooted tree. Many means are the graph must be a tree and all the vertices are away from a one vertex, then it is called the rooted tree and that vertex is called the root. For example, here if you will see here, all the vertices are away from this one, so this is called the root. Now there are some definitions here: parent, children, sibling, insectors, descendants, leaves, and internal vertices. What is the parent? Parent means Baba, father. Child means son, mean Buzura. Siblings in Arabic you can call it Akhu, mean brother. Sectors mean father, father, father. Father, grandfather, grandfather, grandfather. Mean Ajdad. Descendants mean Ahdaf, mean all childrens. Children, grandchildren, like that. Leaves, a vertex of a rooted tree is leaf, it has no children, mean degree 1. It has no children. Internal vertices mean it has children. See here, what is the children? Child. This is A. If you will see here, this is A to B. B is the children. A to F, this is the children. A to G, these are the children. How many children has? 3. B, F, G. These are the children. Parent mean father. Mean definition of parent mean if you have a root and the other vertex is away from this one and edge, then the other vertex is called the, this one is called the children and this vertex is called the parent. So let's see the from example we will calculate here. What is the parent of E is C. What is the parent of father of K? H. What is the father of I? J. What is the father of sorry, this is L. What is the father of L? J. What is the father of I? G. Mean parent. When I talking about the father or parent, you will consider as a parent. So a root is always this one, mean in the first vertex. So what is the root? Root is A, which now we will consider has, now you understand the children. G has, how many children G has? 3. H, I, J. How many children J has? L, M. Which vertices are children of C, D, E? Now the next definition is siblings. Siblings mean in Arabic you can call it as akhu, and in English you can call are the brothers. Now A has three children, B, F, G. Are the brothers. Okay, mean akhu. Which verses are siblings of B? Mean which verses are brother of B, F, and G. Which verses are siblings of H? Mean akhu brothers I and J. Now in sectors Azdad. Which verses are the insectors of E? Mean what is the parent of E? C. C, B, B, A. Up to A you can calculate all the parents. Which verses are the parents of K? H, G, A. Which verses are the insectors of L? J, B, A. Which verses are the insectors of M? J, B, A. See here, and which verses are the descendant? Descendants mean Ahdaf, all children's. Children, grandchildren. C. Which verses are the descendants of B? Descendants of B mean children of B, E, C, and children of C, D, E mean all the childrens. Which verses are the descendant of G? H, I, J, K, L, M. Leaves mean which has no children. F has no children mean degree 1. This one F, D, E, K, L, M, and I. And other verses has internal verses mean which verses has children. They are called the internal verses. In other words, you can remember the verses which has degree more than 1 is called the internal verses. So from these two examples we will give the answers. Which the parent of C, this is the C. Which is vertex is parent of C is B. Children of G, this is a G and these are the childrens, mean H, I, J. Which verses are siblings of H, mean Akhu, brother. This is H and these are his brothers. In sectors of E, this is E, and which are the in sectors mean father, grandfather, like that. This is the father, mean parent, and this is grandparent, and this is also the grandparent. So C, B, A are the insectors. Descendants of B. This is the B, and the words is C, D, E. All children mean Adaf of this one. Then descendants mean Adaf, mean all children. Internal verses, which verses has degree more than 1? Mean which verses has the children? A, B, C, G, H, J. Okay. Now, which verses are leave? Other than internal verses are verses are leave mean the, in other words you can say that which verses has degree 1? F, I, D, E, K, L, M. Once again F, I, D, E, K, L, M. Now we finish this one. Let's start with the next definition. Next definition is a rooted tree is called an M-ray tree if every internal vertex has no more than n children. The tree is called full if internal vertex has m children. Exactly m children. What does mean? Mean how many children have A has 1, 2, 3. G has 1, 2, 3. B has 1. C has 2 children. H has 1. J has 2. Means how many maximum children? 3. This is 3 M array tree mean no more than 3 children. If I say 4 array tree mean no more than 4 children. All are 4 or less than 4. If it is full, mean all children they have all have exactly same number of children is called the full array. Mean full five array mean in all internal vertices has exactly five children. If m is equal to 2, then it is called the binary tree. Mean for m is equal to 2, we call it as a binary tree. For example, in the next example, we will see here which vertices are the, sorry, in the next example, we will calculate, see here, there are three diagrams and check which diagrams, which trees are full array tree or not. See how many children this vertex has. This is the internal vertex, this one. All has two children, 1, 2, 1, 2, 1, 2. So m is equal to 2, so this is a binary tree. And see, this internal vertex has three children, this internal vertex has three children, this one has three, this one has three. Mean kullu internal vertices, all internal vertices has exactly three. So this is full three array tree. See here, this is internal vertex, this one is internal vertex, this one is internal vertex. Okay, so all these three verses has five children. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All these has five children, so this is full five array tree. Now, in the next example, you see this one has two children, this one has three children, this one has three children, and this one has two children. So these two verses has two children and these two has three children. They have no same number of children. So this is not full array tree. This is three array tree, but not full. So graph 1, T1 is binary tree. This is full three array tree because it has three children, and T3 has a full five array tree because it has exactly five number of children. And from this one, you can see that the theorem number 1, how many vertices this graph has? कम बदद निकात 1, 2, 3, 4, 5, 6, 7. कम बदद निकात सबा. Okay. How many edges it has? 1, 2, 3, 4, 5, 6. Check how many. 1, 2, 3, 4, 5, 6. What does mean? Mean if a tree has seven vertices, it has six edges. Saba nikat sitta silk. Mean nikat wahid akbar. Mean silk wahid lagis. So if the graph has n vertices, then it has n minus 1 edges. Mean silk wahid nagis means silk is one less than the number of vertices. So see here how many vertices it has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Mean come the card 13. How many edges must be 12? See here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So mean this theorem hold. A tree has n vertices and n minus 1 edges. Now we will see example here. Here m is equal to 2. We already study m is equal to 2 and how many vertices are internal. 1, 2, 3. M is equal to 2, I is equal to internal vertices mean I is equal to 3 multiplied by 2, 6 plus 1, 7. So kam madad nikat here, Sabah. So answer put here. M 2, I is equal to 3, 2 3s are 6 plus 1, 7. Other N is mean kam madad nikat, Sabah. So this one is no. We can also check here. This is the 3 full array 3 mean m is equal to 3 and how many internal vertices I 1 2 3 4 4 multiplied by 3 12 plus 1 13 so put here m is equal to 3 and I is equal to 4 12 plus 1 is equal to 13 so up to this we finish in the next slides I will explain the theorem start with the theorem number 4